Okay, continuing on with 5.6. Now this is where being able to look at a problem and determine the type of factoring we need to do is really, really important. Okay, so if I have x squared minus 100 equals 0, it is equal to 0. And I notice that there are only two terms. There is no GCF. So if it's two terms and it's only and there's no GCF, I want to know if this is of the form a squared minus b squared. Well, it is. This is the same thing as saying x squared minus 10 squared equals 0, and that factors into x plus 10 times x minus 10. And it does, so it equals a plus b times a minus b. Okay. All right, and it's still an equation, so I got to remember that 0. So now I just set each of these equal to 0. So x plus 10 equals 0, or x minus 10 equals 0. This tells me x is negative 10. This tells me that x is 10. And again, I'm going to check in the original equation. Okay, so does negative 10 squared minus 100 equals 0? 100 minus 100 equals 0. So that checks. Now I want to check if 10 squared minus 100 equals 0. 100 minus 100 equals 0. So this one checks as well. And my solution set would be negative 10, 10. Now, later on in the year, we'll learn a different way to do this that may make it a little bit easier. Okay, x squared equals 36. It is not equal to 0. So I have to write this as x squared minus 36 equals 0. And all I did was subtract 36 from both sides. Okay, well, I notice this is the same pattern as this one. There is no greatest common factor. There are two terms, so the only other possibility is if this is a difference of squares. Well, in fact, this is x to the second minus 6 to the second. So I know that factors into x plus 6 times x minus 6. So if I have x plus 6 equals 0, that tells me x equals negative 6. If I have x minus 6 equals 0, that tells me x equals 6. So again, I'm going to check in my original equation. So I want to know if something squared equals 36. Negative 6 squared, so 36 equals 36. So this one checks. Alright, same thing for the other value. I want to know if 6 squared equals 36. 36 equals 36. So that one checks as well. And my solution set is negative 6, 6. Okay. All right, well, this one looks like a mess. But the first thing that I have to take care of is that it needs to equal 0. Okay, so I'm going to have to subtract x squared from both sides. Notice I'm going to line it up. And I have to add 4x to both sides. So 3 minus 1 gives me 2x squared. 10 plus 4 gives me 14x equals 0. Okay, all right, two terms. So the first thing I'm going to do is look for a greatest common factor. So my GCF, there is one here. I notice both of them have x's and both of them are even numbers, is 2x. So I'm going to write this as 2x times x plus 7, and that still equals 0. So now 2x equals 0, or x plus 7 equals 0, which tells me x is 0, or x equals -7. Okay. Now once again, look at all the opportunities to make mistakes here. Okay, it looks like I did it right, but even a sign error will make it a mess. So I'm going to go back up and check each of these solutions in my original equation. So 3 times something squared plus 10 times something equals something squared minus 4 times something. Okay, 0, 0, 0, 0. So that means 0 plus 0 equals 0 minus 0. That checks. So that one's taken care of. Okay, so this one, I don't have a 0 in this one, so this may take me a little bit longer. Okay, so this is -7, -7, -7, -7. Okay, so -7 squared is 49. So 3 times 49, 10 minus -7 minus 70. I want to know if that's equal to 49 plus 28. Well, this is 147 minus 70. 49 plus 28 is 77. And look at this, so is this. So they check. So 0 and -7 is my solution set. All right, now once again, I'm hoping that as you see us do one, that maybe you'll go and try the other one on your own. Okay, once again, I got a big mess here, but the first thing I need to do is make it equal to 0. So that means I'm going to subtract 4x squared, and I'm going to add 3. So that gives me x squared minus 5x is equal to 0. Okay. Two terms. Looks like they have an x in common, so my GCF is x. So I get to write it as x times x minus 5 equals 0. So I'm good. So I set each of my factors equal to 0. So x equals 0 or x equals 5. Okay, now my check is going to be nasty again. It's really worth the time though. It saves you from so many errors. So 5 times 0 squared minus 5 times 0 minus 3. I want to know if that's equal to 4 times 0 squared minus 3. That gives me 0 minus 0 minus 3 equals 0 minus 3. That is true. So that checks. All right, the 5 is going to take us a minute. So 5 times 5 squared minus 5 times 5 minus 3 equals 4 times 5 squared minus 3. Okay, 5 squared is 25 times 5 is 125 minus 25 minus 3. 5 squared is 25 times 4 is 100 minus 3. So that gives me 100 minus 3, which is 97. And it checks. So there you have it. Whoops! And I'm so sorry you can't see that, so I'll leave it up for a second. So again, as you're doing this, make sure you follow the procedure, and in particular, think about the type of factoring you're going to do. Okay, you're going to want to put big red stars by this one. These are deceptive. You're like, well, it's already factored. This is not equal to 0. These are not equal to 0, which means you cannot factor it until it's equal to 0. Okay, so I'm going to add 18 to both sides. So that gives me x plus 2 times x minus 7 plus 18 equals 0. This plus sign here gives me all kinds of problems. I have to turn this into a factor times a factor, which means my first step here is I'm going to have to multiply this all out. So I'm going to have to multiply x times x minus 7 plus 2 times x minus 7 plus 18 equals 0. So x squared minus 7x plus 2x minus 14 plus 18 equals 0. So that gives me x squared minus 5x plus 4 is equal to 0. Okay, so now I need to get this back into factored form. 3 terms, leading coefficient is 1. So I'm going to look for 2 numbers multiplied together equal 4, added together equal negative 5. They are negative 1 and negative 4. So this factors into x minus 1 times x minus 4 is equal to 0. So this tells me that x minus 1 is 0, or x minus 4 is 0, which means x is 1, or x is 4. Now once again, I'm going to check those back in the original equation. So something plus 2, something minus 7, I want to know if that's equal to negative 18. So 1 plus 2, 1 minus 7, that gives me 3 times negative 6, which is negative 18. So that checks. I'm going to do the same thing with 4. So 4 plus 2 times 4 minus 7 gives me 6 times negative 3 equals negative 18. It does. So there's my other solution. So my solution set is 1, 4. Got a little brain snafu there. Couldn't remember what I was supposed to write down. Okay, last example in this section. Okay, once again, it is not equal to 0, even though it's factored. So that means I'm going to have to set it equal to 0. I'm going to subtract 2 from both sides, which gives me x minus 1, 5x plus 4, minus 2 is equal to 0. Alright, so here I'm going to do exactly what I did. I've got to turn this into a product times, or a factor times a factor. This just throws me way off. So, if I multiply this, that gives me x times 5x plus 4 minus 1 times 5x plus 4 minus 2 equals 0. So 5x squared plus 4x minus 5x minus 4 minus 2 equals 0. So 5x squared minus x minus 6 equals 0. Okay. 3 terms, no GCF. This throws me into a bit of a tizzy. So what I'm going to do here now to factor this, I have to multiply. So I'm looking for two numbers whose product is negative 30 and whose sum is negative 1, and they are negative 6 and 5. And I use that to split the middle term. So this becomes negative 6x plus 5x. Then I bring down the, that's a terrible 5. 5x squared minus 6. The whole point of doing this is so that I can group these. I've got a plus sign so I don't have to do anything fancy. Greatest common factor here is x times 5x minus 6. The greatest common factor here is 1. 5x minus 6 equals 0. I have a common binomial factor of 5x minus 6. And when I factor that out, I'm left with x plus 1 is equal to 0. Okay, so if 5x minus 6 times this equals 0, that equals 0. Or x plus 1 equals 0, add 6, divide by 5, subtract 1. And checking this one, I'm not gonna lie. Well, it actually won't be bad. Okay, so let's check. I'm gonna leave myself plenty of room down here. I'm checking it back into the original equation. X minus 1, 5x plus 4, and I want to know if that's equal to 2. Okay, so let's try the 6/5 first. Alright, so 6/5, 5 times 6/5 equals 2. Okay, 6/5 minus 1 is, that's going to be 6/5 minus 5/5. So that gives me 1/5 minus 1 times, and those cancel, 6 plus 4. And I want to know if that's equal to 2. Okay, so 1/5 minus 1 is going to be 5 over 5. So negative 4/5 times 10 . Uh-oh, I've done something wrong here. Okay, we're just going to pretend. I know these are right, so we're just going to pretend that I can't believe I did that on the very last 30 seconds of a 20-minute video. All right, so never mind. I'll figure it out and I'll tell you later. All right, so that's it for that lesson.